Assalamu alaikum. My name is Sayyid Rafi Hashmi. The topic that we are going to present is using machine learning to categorize EEG signals from the brain to words. Imagine living in a world where we could control everything from our mind, like toggling your room's light or fan, controlling your air conditioner's temperature, browsing over internet, all from your mind. Also making it possible for a mute person to talk. Isn't it just amazing? Let's see how this could be possible. So here's the list of content of our today's presentation. I would be explaining you the concept of EEG and brain waves. Then we will head toward how we can capture these brain waves through EEG headsets and process them with the help of a controller. After that, Mr. Asadullah would tell us about what is machine learning and how we can use that in our project. Afterwards, Mr. Zain will be introducing some mesmerizing applications of the project. So let's get started. EEG, electroencephalography, is an electrophysiological monitoring method to record electrical activity of the brain. Typically, it is non-invasive procedure in which the electrodes are placed along the scalp that measures the brain's electrical activity. Now, let's have a look what are brain waves. The average human brain contains about 86 billion nerve cells called neurons. Neurons communicate with each other by sending chemical and electrical signals. So every time we recognize a familiar face, hear a voice, learn something new, or talk, like now, millions of neurons are communicating with each other. Let's take an example of a person having neuromuscular disease causing speech disability. Whenever he tries to say something, his brain sends signals to the body parts that are contributing in creating a speech, but due to the disease, these signals are not transmitted to the body parts. So, the primary goal of our project is to create such a device that would capture those brain waves and convert them into a speech that would help the person having speech disability. Here are some major types of brainwaves that our brain produces in different scenarios, which includes delta and theta that are generated when in deep sleep or meditating. Alpha waves are produced when we are relaxing. Beta waves are produced when we are focusing or thinking intently. Gamma waves are produced when we are in conscious and perceptive thinking. Now let's take a look of the hardware of the project. Here is the Ultra Cortex Mark IV EEG headset that we will use to record the brain waves through its electrodes. The Ultra Cortex is an open source 3D printable headset intended to work with any OpenBCI board. It is capable of recording research grade brain activity, that is EEG. The Ultra Cortex Mark IV is capable of sampling up to 16 channels of EEG. Next is the OpenBCI Sight and Biosensing board, which is Arduino compatible, having 8 channel neural interface with a 32-bit processor. At its core, the OpenBCI Sighten board implements the PIC32 microcontroller, giving it a lot of local memory and fast processing speed. The OpenBCI Sighten board can be used to sample brain activity like EEG. The board communicates wirelessly to a computer via the OpenBCI USB dongle. It can also communicate wirelessly to any mobile device or tablet compatible with Bluetooth Low Energy. So this was all from my side. Now Mr. Asadullah will continue the presentation.
Bismillahirrahmanirrahim. Assalamu alaikum. Before going to our main topic, we should know about what is machine learning. As we know about the artificial intelligence, as we can see in the diagram, so we know artificial intelligence is a big umbrella under which machine learning and deep learning comes. So the question arises, so what is machine learning? Machine learning is basically a machine learning provides the system the ability to automatically learn and improve the system from experience without being explicitly programmed. Machine learning and its type. Basically, there are three types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. So, in supervised machine learning, for training the model, we give labeled data to predict the future events. In unsupervised learning, we use information for training that is neither classified or labeled. And now about reinforcement learning. Reinforcement learning is a learning method that interacts with its environment by producing action and discovers error or reward. Combination of machine learning and EEG. We know machine learning work with the data, so our first step for applying machine learning model, we should have a sufficient amount of data. We collect the data from the brain when the subject is thinking about saying certain words. From there, I will train a machine learning model with the collected data and use the resulting model to then read the subject's brain wave in the real time into words they may be trying to say. As you can see in the diagram, brainwaves comes which our sensor is collected these waves. This is data for our model. Here we are using categorization algorithm, that is a machine learning algorithm, and after that we get our result in a word form, then we will convert into speech. Thank you.
Assalamu alaikum. This is Zain Mansoor, and today I'll be discussing about three main applications of converting brain waves to words. Number one, communication. Number two, control. And number three, user state monitoring. Communication. We can create a communication bridge between human brain and the external world. The hardware uses the signal from human brain and decode their silent thought, and it can be used by the handicapped people to express their opinion and views. Control. It facilitates the hand-free application, bringing ease and comfort to human beings through mind controlling. It requires brain signal. No muscle intervention is needed. As you can see in the picture, we can control anything like games, robots, etc. User state monitoring. Brainwaves works as a measuring tool that contains information regarding human state. Human state can affect the mental tasks associated with the recorded brainwaves. By looking at the brainwaves, we can even monitor the user current state. We can even prevent or diagnose any disease in the user. Firstly, we will record our brainwaves using hardware. Then we will extract features from those recorded waves using machine learning. Then those extracted features will be used to obtain our desired output. In future, you will see a lot of applications like this. Thanks for watching our presentation.